Hello, in this tutorial I'm going to show you how to do this effect, making the columns with this animated character using Pulldownit plugin, and also adding more debris with particle flow in 3D Max. Thanks Andres for the option org, by the way. So I'm going to show you how to break the columns and also adding those small debris with the particle flow tool. So let's start. This is our set. The orc is animated with motion keys, and we have to break the columns when the character hits them. For this, we are going to start breaking the third column because the setup for all columns is exactly the same, and this way I have more time to explain later how to add more debris with particle flow. So let's hide the walls because we don't need them for the explanation, and let's go to shader this column when the orcs hit it. For this, just we have to open Shade tool in the Pulldownit toolbar, select our column, the shader style uniform, the number of fragments is fine. So click on Shade button. Pulldownit is shattering the object. There we are. Our fragments have been created, and we have to create more fragments in the impact area with the arm of the orc. For this, we are going to use local shader style. Click on preview and place the cloud of points in the impact area with the arm. Modify the width. Important thing is placing the cloud of point in the impact area. Increase the number of fragments to create more of them, and let's click on Shade button. Now Pulldownit is reshattering the model, adding more debris in the impact area. Here we are. Let's check the model. We have got more smaller fragments in the impact area, and still the fragment from the first shader operation. So now let's go to create a fracture body for the column. For this, select any of the fragments, click on create fracture body. This is our selection of fragments. Okay, in this window we can rename our fracture body like a broken column, for example, and click on OK. The model turned orange, that means the fracture body has been created. So now we have to set some dynamics properties for the model for breaking it correctly in dynamics. Switch on stresses view, and with this is the distribution of hardness. Weight areas are easy to break. As we want only the object starting to break in the impact area with the arm, we are going to remove completely customized parameters. So you can see now only the white area is only in the impact position with the orc. And also we don't want the column starting to move until being hit. So for this, set it as static. And finally, in propagation scheme, set it to local. So the column breaks only when impact with something else. Switch off stresses view, and let's set the rest of objects in dynamics. Set the ground as static so fragment doesn't fall to the void, and set the skin of the orc as kinematic because it is animated, and also set it as mesh animated because the skin is deforming. This way Pulldownit will take in account the mesh deformation when computing dynamics. Let's start computing dynamics for this column to check it. Okay, there is an issue here. I have my start frame is not set correctly, so let's go to the start frame of our simulation. It's about 190 and set it as our start frame for dynamics. Okay, start frame 190. Let's start computing dynamics. Also changing in the slider. And let's start computing dynamics for our check bake keys. And click on play. Now the column start to break. Okay, very nice. But here there is another issue because let's stop this because the base of the column is breaking and moving, and I don't want it to move at all. So for this, it's very easy to modify it with Pulldownit. Let's go to basic fractures, switch on stress view, and let's go to use advanced fractures to prevent the base of the column from moving. Just select the fragment here, data blue, and select the fragment we don't want to move and set them as static. Okay, they appear in the list on the right. Select them in the viewport and click on set static. They are black, that means the fragment shouldn't move in dynamics. Switch off stress view and let's compute again. Okay, everything is fine. Let's compute again with this modification. Now the base of the column shouldn't move when the columns is breaking. Okay, very nice, as we wanted. The top part is falling, and now when hitting the ground I expect it to break again. Okay, here we are, very nice. Secondary cracks. Let's stop this and check the destruction of the column. Okay, it is taking perfectly the momentum of the arm of the orc and breaking again when hitting the ground. So I like the result. Let's stop this and add the last columns in the simulation. The setup is exactly the same. You have to place the orc near the columns, and now select both of them. We are going to shatter both at once. Select uniform shatter style. Number of fragments about 50 is enough for our first shatter, and click on shatter button. This is for creating some large fragments. Then we refine the result, creating more fragments in the impact area with the orc. So the fragments are there. Let's go to create small fragments in the impact area. For this, as before, select local shader style, click on preview, increase the number of fragments to create more of them, and place the cloud of point in the area where we want to create more fragments. Increase the width to make them a little bigger. Okay, that's something. Okay, here we are. Now let's shatter this column, reshatter it, increase a little the number of fragments, and click on Save button. Okay, it's done. Let's check the fragments, and let's do the same with the other column. Select any of the fragments, click on Preview, place the cloud of point where you want to create more fragments in the input area with the arm. Okay, and click on Save button. Okay, here we are. Now we are going to create fracture bodies for both columns. So select this one is already created. Okay, it is orange color, and we have to create another fracture body for this column. So select any of the fragment, click on Create Open Basic Fracture, click on Create Fracture Body, rename it as Broken Column 2, and click on OK. It turns orange, that means the fracture body has been created. Switch on Stresses View to set some dynamics properties. As before, we want it starting to break only in the input area with the arm, so remove clusterize parameter, and also set it as static because we don't want the column to move before being hit by the orc. Finally, in propagation scheme, set it to local, so the column breaks only when being hit by another object. And set the base as before, the fragment on the base, set them as static in advanced fracture, so they doesn't move in dynamics. Click on set static, they turn black, they shouldn't move. Let's switch off Stresses View and make the same with the column at the other side. Select any of the fragment, click on Create Fracture Body, rename it as Broken Column 3, click on OK, switch on Stresses View, remove Clusterize parameter to let only as weaker area the area of impact with the arm of the orc. Okay, this is the white area in the Stresses View. Set it as static and propagation scheme to local, so it only breaks when colliding with something else. Here we are. Let's add the base also as static, so it doesn't move in dynamic. Switch off Stresses View. Let's start computing dynamics, but there is we have to do something else because those columns we don't want them to break until a specific frame, because it is possible fragments from the column behind hits those columns and they start to break because of that. So for preventing this from happening, we have to set those columns as unbreakable until a specific frame, the frame where the orc hits them. So the frame is number of the frame is about 244. Okay, so set this frame at a start frame for breaking. Make the same for both columns, unbreakable until frame 244. This way, the columns shouldn't break even if they are hit by any other object in the scene. So let's start computing dynamics for our set of columns. first column start to break in a violent way. Very nice. Okay, the column is falling because I have forgot something. Let's stop this and go back to fracture, basic fractures. Okay, I think I have to, when using unbreakable anti-frame, I have to set also activation breaks upon impact in some situation for preventing the columns moving in advance. So set it as activation break upon impact. Let's check if this fixes the issue. Okay, so the column now is standing, but the other column happens the same issue. So let's stop this and make the same change. Set the column and set activation breaks upon impact when using unbreakable anti-frame. So let's compute the simulation with this fix. First column start to break, the other column stand, and now let's see if they breaks when the arc hits them. Okay, look at the top part of the first column. When falling to the ground, it shatter again, but isn't affecting this column because it is set as unbreakable anti-frame. So now let's see if the arc breaks the column when hit them. Okay, very nice. They are starting to break violently. Very nice. Let's compute a few more frames and check the result. Let's see if this column is breaking again when hitting the base or the ground itself. Okay, it's breaking again, nice. But the third column, I don't like its dynamics. Okay, it is moving in a weird fashion. Let's check it. Stop this and check. I like the columns on the left side, the way they breaks, but the third column, I don't like this big chunk here sliding over the base. I would like it to break when hitting the base, so I'm going to, I think it is too hard, so let's reduce its hardness, select it and reduce its hardness to make it easier to break. Okay, reduce it to 50 units, and let's compute again the third columns in dynamics. It's a matter of tweaking parameters to make objects harder to break or weaker. Okay, Pulldownit, this is pretty fast and very easy to be done. Okay, now let's see if when the arcs hit the columns they start to break, and we have fixed the issue with the column on the right, and it breaks in a more believable way. Yes, it is its motion is different now, and let's see if the big part is breaking again when colliding with the base of the column. Okay, it's starting to break, nice, and creating secondary cracks when colliding with the ground as well. So I like the result. Let's finish the simulation and check the final result with Pulldownit. It's done. Let's check the dynamics. Okay, nice, breaking both columns. Let's see from, let's reduce the playback speed to see it clearly. First column breaking, and the last one breaking as well in a nice way. Okay, let's check it from this other point of view. The columns are taking the momentum, perfectly the momentum of the orc when breaking. That's very nice with Pulldownit. So I like the result. I'm breaking again. Look that they are breaking again when colliding with other objects. Okay, these are secondary cracks, work automatically with Pulldownit plugin. Okay, fragment breaking again when colliding with the ground. So I'm happy with the result. Look at those fragments breaking again, very nice effect. I'm happy with the result. So at this point, let's clean the scene, open Manage PDA Wall, and click on Delete all PDA bodies. This way we delete all PDA data and let only keys in the scene. You can go back and forth and edit them, retiming the animation, whatever is your workflow with motion keys. So it's a good moment to save the scene with a different name just in case. Can rename it as Control keys. And let's start adding more debris with particle flow to improve the destruction effect. Actually, we could add more debris using Pulldownit plugin itself, but for very small fragments and many of them, it makes more sense using particles, because in this way it is easier modifying the amount of particles, the size of the little fragments, and besides controlling the dynamics of particles, of debris, in a different fashion than the dynamics of big fragments. So we are going to emit our particles from the inner faces, the faces with the green material applied. For this, we have to create first a particle flow source. So set wireframe mode to see the icons clearly, and create a particle flow source on the viewport near our columns. Place it near our columns. Let set its position to the origin of the viewport, okay, and place it near the columns just to select the icon easily. Go back to shade mode. I miss the icon. Let's move it up a little. Okay, so now we are going to select our fragments for particle emission. I'm going to start emitting only from the column in the right side, then adding the rest of the column later. So for selecting our fragments, first things I'm going to do is freezing the org model, just to not selecting it by mistake. Freeze the org model, and now select the fragments we want to emit particles. The viewport, just include more fragments in the selection if we need them. For example, those big fragments here, include them as well. I think it's fine. So let's remove some fragments I don't want to emit particles from. Add also this one. So this is our selection of fragments for particle emission. Let's create a group for them. Rename it as emit debris, for example. This is just to select the group easy. Okay, now we can select our fragment for particle emission and the particle source itself, and isolate selection. Okay, here this happened because I have to make some modification in the particle flow source before starting tweaking parameters. So open particle view. This is our emitter, and let's remove all these operators because we don't need them at all. Now let's select again our source and objects. Here we are. These are the fragments which are going to emit particles. And let's start adding operators in the particle flow. First thing we need is a emitting particle from the fragment, so I'm going to add a position object operator and simply select our group and include it in the operator by selecting it. Okay, now you can see the particles appear on the surface of the fragment. Let's increase the amount of particles to 300 to get more of them. But here the problem is the particles are being emitted from all faces, inner faces and the faces in the surface of the model. And I want then only emit from the inner faces. To fix this, it's very easy. In 3D Max, I have just to add an edit mesh modifier to the group. And here in the position object operator, there is an option which is location of the particles. It is set to surface, but I can select faces for emission. So now simply let's go here, set face view, select any of the faces with the green material, and here in material, when selecting any of the faces, the ID of the material is displayed, and we can select all faces with this material applied. So now here in the particle flow, select emission from faces. Okay, click on select location selected faces, and here we are only our interfaces with the green material applied are emitting particles, but the particles aren't following the trajectory of the fragments. To fix this, you have to make another modification, which is check lock on emitter. So now our particles are following perfectly the motion of the fragments. Let's increase the amount of particles in the birth operator to get more of them. Okay. So now we have a set of particles attached to the interfaces, and we are going to use those particles themselves to emit our debris. For this, first I'm going to change the icon of the particles to circles, because this way I differentiate them from the second set of particles, and this icon is more intended for emitter shape. So let's follow by closing this and go back to complete view, and let's add our second set of particles for creating debris. Check the simulation. Okay, now we have to add another operator here in particle flow, which is a span operator. It is going to allow us to emit particles from each one of the circles in the screen. Add also a display event for the new particles. So now you can see those new blue sparks appears in the viewport. These are our particles for creating debris, but they aren't following the trajectory of the fragment. We have to set by travel emission, spawn by travel distance to make them following the trajectory of the fragment. However, you can see the motion is very chaotic, and we have to make several adjustments to get the behavior of the particles more believable like debris. So first we are going to add some other dynamics elements. We are going to use to add a gravity force on the scene to make the particles fall because of the gravity, fall to the ground because of the gravity. So here in force, add a gravity space warp. Okay, and let's place it near our particle flow icon, just to select it easy. Place it near the other icon. Okay, but nothing happens. The particles aren't affected by the gravity because we have to include it also in particle flow by adding a force operator here in the second event. Okay, add a force operator and simply include our gravity in the list. Now the particles are falling because they are affected by the gravity, but they are passing through the ground because we have to add another dynamic object in the viewport, which is a deflector. So let's go to deflectors and add a deflector over our ground object. Add it in the way it matches it fits to the surface of the of our ground. Place it over the ground and make it extend it, covering perfectly all our ground objects, so particles cannot pass through it. Let's place it better in the front view, okay, making sure it is placed exactly fitting the surface of our ground. So now again it doesn't work because we have two particles are passing through the ground, because we have to add the deflector to our particle flow chart. So let's go back to shade mode, and here in particle flow let's create a collision operator, collision event, okay, and include our deflector in the list. Select it. Now the particles are colliding with the deflector and falling because of the gravity, but still the behavior of the particles is very chaotic, and this is because we have to adjust a few dynamics properties. First, bounce is set to 1, and this is a lot, so let's reduce it to 0.3. Now it is much better, and also the particles are sliding over the ground, so let's increase friction about 50% to stop them when colliding with the ground, maybe less. And also in bounciness, let's increase variation to make some of them bouncing a little more, okay. So this is more believable already, but we have still to make more adjustment to get our debris, a realistic debris for the columns. So in a span operator, let's inherit speed. Let's increase variation to create some chaos on the motion and also divergence. So now our motion is more realistic, the motion of the particles. Okay, I like it. I think it's fine. It's a matter of working with particles. It's a matter of tweaking parameter until getting the look you want. So now let's. I think gravity is too high, so let's decrease it to 0.1. Now I like it much more now. More believable behavior of debris flying away. So now I think I have too many particles. Let's reduce the amount of them. In expandable, reduce it to 80%. Okay. And inverse operator, reduce the amount because it was too high to 300. Okay, in any case, you can modify the amount of particles at any moment, and it's very easy. But I think it's fine now. Just in case, let's reduce gravity still a little, but not. I prefer 0.1 for the gravity value. So at this point, let's also reduce the speed, inherit speed 80% only to get more chaotic behavior of particles. So at this point I like the behavior of the particles. I'm going to add the other column to particle view to emit also particles from it. For this we make the same, select the fragments I want to emit particles from in this area. Let's unselect the deflector, okay. Let's add any fragment, important fragment we miss in the first selection. This big fragment here should emit, and also remove the fragments we don't want to emit. This one here, I don't want it to emit particles because it is not breaking. Let's see from the other side. I want to remove this fragment. I cannot for some reason. Let's try again. On the other side is fine. Okay, here we are. So this is my selection of fragment for emission in this column. Let's create a group. I cannot because probably I have selected something which is preventing me from creating a group. Let's check the scene. Okay, here we have selected a couple of bonds in the troll object, so unselect them. Let's see if I can create the group now. Let's start again. Better, I'm going to hide the troll, the OR completely because it is causing issues in selection. So hide it completely and select our fragment for particle emission. Here, check the selection and create. Selection is fine, so create our group for particle emission. Now it allows me to create a group, rename it as emit group 2. This is just to select it easily for particle flow operation. Okay, so now let's go again to emit particles from the new group. For this we have to open particle view, and here in position operator add the new group by clicking in by list and selecting our group. Okay, here we are. The fragments are already emitting particles. It is as easy as this to add more fragments in particle flow. Okay, very nice. So now we have to check if everything is going fine with the new column in the simulation for particles. Let's select our particle flow icon. For some reason I cannot select this icon. Let's try again. Okay, I'm not in selection view. Okay, now let's select our particle flow icon and the emitter groups and isolate the objects to check for issues in the particles. Okay, but everything is fine. The new group is emitting already only from the inner faces, so there is nothing to fix. Go back to complete view and let's check the simulation. I like the behavior of the particles. So I'm going to move forward by converting those particles to geometry for creating our debris. For this, I like to use again Pulldownit plugin to create our debris instance. Let's create a box in the viewport, and with Pulldownit share it with the default parameters, uniform share style. Click on share button, and now let's select our fragments. Let's select the cube, the shutter cube in the viewport, and isolate it to remove the fragments. Let's isolate only the cube. Okay, so let's remove the fragments I don't want to instance as debris. I don't want to instance the fragment on the corners because they will look weird as a debris, okay, for the columns. So let's simply remove those fragments on the corners and edge of the cube. This is because the columns are round, so it looks weird debris with the shape of corner. So now here we are. These are our fragments for creating debris. Go back to let's remove this one as well. Let's go back to complete view, and let's add this those fragments to particle flow to create our debris. For this we have to group them, rename this group as instance debris. Okay, and go back to particle view. We have to add a new operator, which is shape instance. So let's include it in the simulation, and simply click on particle geometry object and select our Pulldownit fragments. Now it is instanced, but nothing happens because we have to make another change. Here in display we are displaying ticks, and we have to display geometry. Okay, here we are, and also in selected change it to geometry. Now the fragments are displayed in the viewport, but I'm instancing the whole group per particle, and I want to instance the members of the group. So simply change here separate particles for group members. Now here we are. We have our fragments our particles instanced as debris, but they are too big. So here in scale, let's reduce its scale to 50% to make them smaller. Okay. It's very easy to control the size of the particles with particle flow, and very quick. So reduce scale to, I want very small debris, reduce scale to 30%, and increase variation to make some of them bigger than others. more realistic look of debris. Finally set them as 40%. Now you can see the look of our debris. It's more realistic, more believable. Let's make still some check for issues and make some modification if needed. Okay, let's set the start frame of the simulation to the start frame when the columns start breaking. Okay, for not seeing those circles in advance. Let's see how those particles are adding detail to the scene. Okay, we'll select our particle flow icon, and here we can very easily disable all our particles, so you can see the difference, the detail we are adding with those small debris all over the scene. So we are done with particle flow. It left only to replace this green material for a more realistic material. I'm going just to sketch the way for doing it. We have to select the PDI cut material and replace the green material for another one. In this case, I'm going to use a bitmap of kind of stucco, and also in the bump map or displacement map, add another bitmap to create the rough look of faces. Here we are, but we have still to lay out the UVs because they appear they aren't set, but you can see now the look is more realistic. Let's hide everything except the columns to create the UVs for the inner material. Let's select only our columns, freeze the deflector for not selecting it by mistake, and here create a UV map modifier and create our UVs for this is a little messy. Let's select face better and simply tweak the UVs until getting the look we want for inner faces. I think 0.5 is better for little debris, but the let's change to box mapping. Okay, I think it's better, and increase the tiles to 1. Here we are. You can see now the detail over the surface of the fragments. So this is just sketching the way of doing it. Let's show the complete view, and let's unhide everything to play the final scene with Pulldownit extrusion and adding debris with particle flow. Let's unhide everything, also the walls. And drag all of this because this helper object, I don't want to see them in the final playback. Go back to realistic shading, and those circle emitters. Okay, I have forgot to add debris to the first column, but in this way you can see the difference between the first column, which is breaking nicely, but it lack of the detail of the we have added to the other columns. Those circles here, I think I can get rid of them. Yes, I can, but by open particle view, and here in display set it to none, so they aren't displayed in the viewport. Okay, so now this is our final result. Hope you like it. Bye.